As expected, since we've been talking about arithmetic sequences, we're now going to talk about arithmetic series. So an arithmetic series is just the sum of the terms of an arithmetic sequence. Okay, we know series means just to add everything up. Okay, when you have an arithmetic series, either it's going to be finite or infinite. Okay, all series are. So, if it's a finite series, that means you're adding up a countable number of terms. If it's infinite, you're actually trying to add up infinitely many terms. Okay, we're going to start with talking about how you add up a finite arithmetic series. So in the box, there's a couple of formulas that you can use to add up the first n terms of an arithmetic sequence. Okay, and out to the side here, I've got a reminder of how you can recognize an arithmetic sequence. When we did when we did the graph of the arithmetic sequence, we did that because it showed you how you can easily recognize an arithmetic sequence, or series in this case, from its formula. Okay, so here, if you look at this statement in brackets, we've got the sigma notation that's telling you to add everything up. But what are we adding up? Terms of the form d times I plus c. Okay, that's indicative because it's like the mx plus b. It's indicative that we're adding up terms of an arithmetic sequence. Okay, I is the index here, d is the common difference. Okay, so as long as you're dealing with a series, you're adding up terms of the form mx plus b or di plus c, you're dealing with an arithmetic sequence. So you're going to know to apply the following formulas. Okay, so let's read about it. Like I said, there's two different formulas. If an arithmetic sequence has first term a1 and common difference d, then the sum Sn of the first n terms, called the nth partial sum of the sequence, is given by the following. Okay, so here's the first formula for adding up the first n terms. That's what the Sn means. You're summing the first n terms. It's equal to n divided by 2 times a1 plus an. Okay, the other formula you can use to sum the first n many terms is going to be n divided by 2 times the quantity 2 times a1 plus n minus 1 times d. Okay, so both formulas can help you add the first n many terms of an arithmetic sequence. Okay, these only apply to arithmetic sequences. Okay, so is there a preference? Which formula do you use? Does it matter? Well, yeah. Here's what you're going to do. Okay, right here. The formula on the left is used when you know the first and the last terms. Okay, you can see in the formula, I see a1 and an, the first and the last. I have to know those guys to plug them in. Okay, well, what if you don't have the last term? Okay, if you don't know the last term, you're going to use the second formula. Okay, because the second formula, you have to know a1 and you have to know the common difference. Okay, notice in the first formula, you don't need the common difference. Okay, so basically, it all depends on what you have at your disposal. That will determine which formula you're going to choose here. Okay, if you're interested in where these formulas are coming from, I will do a justification on the last page of this note packet, and that's an optional video. If you're just curious about where things come from, feel free to take a look at that. Okay, all right, so let's do some examples here. Okay, in example 8, we are going to evaluate S21 for the arithmetic sequence 48, 44, 40, 36, and so on. Okay, so when we look at this, okay, as it's given, this is an arithmetic sequence. Okay, how do we know that? We're told that, but if you look at these terms, okay, to go from the first term to the second term, you're subtracting 4, we're subtracting 4, we're subtracting 4. So our common difference here is -4. Okay, what we want here, this is an infinite sequence. Okay, it has ... It can go on forever, but we're trying to calculate S21. Okay, this is the 21st partial sum. That's what we can call this. What this means is we want to add the first 21 terms of the sequence up. Add the first 21 terms of the sequence. Okay, so you could sit here, we've got the first 4 terms, you could keep subtracting 4, and you could actually write out the first 21 terms and then add them all up. Okay, that's tedious, but that's totally plausible. You can do that, or you can apply one of the formulas we just talked about. Okay, so the question's going to become, which formula do I use, the first or the second? Okay, well, based on what I know right now, okay, I don't have the last term. The last term would be the 21st term. So like I said, you could write out all the terms and figure out what the 21st term is, but that's going to take a while. Okay, we already have enough information to use the second formula. Okay, we know A1. Okay, A1 is 48. It's the first term. And we just figured out what D is. Okay, so we have everything we need to use this second formula here. All right, so we're going to plug into Sn is equal to n divided by 2 times 2 times A1 plus n minus 1 times D. Okay, and since we're doing the 21st partial sum, that means the n value has to be 21 here. So everywhere you see an n, replace it with 21. So S of 21 is going to be 21 divided by 2 times 2 times A1. A1 is 48 plus 21 minus 1 times the D value, which is -4. Okay, so just doing this computation will tell us the 21st partial sum. If I add up the first 21 terms of the sequence here, meaning 48 plus 41 plus 40 plus 36, all the way out to the plus the 21st term, this is what it's going to add up to be. Okay, I'm going to go to my calculator to compute this. Okay, so let's see, we're going to have 2, I'm going to do what's in brackets first. So 2 times 48 plus 20 times -4. Okay, this will give me the quantity in brackets. Okay, and then I've got to multiply this by 21 divided by 2. Okay, so times 21 divided by 2, and then here you go. Okay, the answer is 168. Okay, and that's it. Okay, so if you add up the first 21 terms of this sequence, okay, this is the number you're going to get. Okay, all right. Again, if you wanted to just write everything out, add it up, that's plausible, just tedious. Okay, let's do another one. In example 9, we're going to look at a new sequence here. Recall that the set Z of integers is the set of natural or counting numbers together with their negatives and the number 0. Okay, so we've been talking a lot about the counting numbers, the natural numbers, and that's these guys. Okay, but if you're talking about the integers, you just tack on these numbers with their negatives and the number 0, because 0 is not a counting number. Okay, sometimes, or actually a lot of the times, the counting numbers are referred to as the set of positive integers. Okay, so the set of positive integers is the same thing as the natural numbers. Okay, all right, so focusing on the integers here, in part A, we are going to evaluate the sum of the first 200 positive integers. Okay, to do this, let's write out the first few terms of our sequence. Okay, we are adding the first 200 positive integers. Okay, so we're going to start with 1. Okay, so basically we're adding the first 200 natural numbers. Okay, so this is our sequence here. Okay, it is clearly arithmetic because to go from one term to the next, we add 1. Okay, so the common difference here is 1. D is 1 here. Okay, all right, so what we're trying to find, if we're evaluating the sum of the first 200 positive integers, we're adding up the first 200 terms in the sequence, so we're trying to calculate the 200th partial sum. Okay, so if you're doing this problem, okay, you can actually use either of the formulas. We have all the information we need to do both formulas. Okay, here we have the d value and we have a1. The first term is 1, but so we can use the second formula. We can also use the first formula because we know an, we know a200. Okay, this sequence is going to keep going and the last number is going to be 200. So the last term an, which is a200, okay, that's going to be 200. Okay, so you can plug and chug into either of the formulas and get the answer here. It should give you the same thing. Okay, I'll start by applying the first formula just so you can see you get the same thing. The first formula is Sn is equal to n divided by 2 times a1 plus an. So if we want the 200th partial sum here, our n value is going to be 200. So plug 200 in everywhere you see n. We're going to get 200 divided by 2 times a1. The first number in this sequence is 1. The last number is 200. Okay, so this is going to be 100 times 201. Okay, if we calculate this, we will get 100 times 201. And so here is the sum of these numbers. Okay, so if you add up the first 200 natural numbers, okay, this is going to be your answer. Okay, all right, we could have used the other formula to get this. Okay, so I'll put this in a different color. If we use the other formula, we'd be applying this guy. Sn is equal to n over 2 times 2a1 plus n minus 1 times d. Okay, so again, n is 200 here, so plug that in. We know a1 is 1, and we know that d is positive 1. Okay, so if we simplify this, this is going to be 100 times 2 plus 199. Okay, so this is going to be 100 times 201, and again you get 20,100 as your answer. Okay, so this case either formula works. All right, so let's take a look at a little twist on this problem in part B. Okay, we are going to evaluate the sum of the first 90 positive odd integers. Okay, so the twist here is that word odd has been thrown in. Okay, so we're going to do this the same way. Okay, start by writing out the numbers in the sequence. Okay, so the numbers have to be positive, so we're going to start with 1, and they have to be odd. Okay, so this is going to be 1, 3, 5, 7, 9, and so on. Okay, and we're adding the first 90 terms in this sequence. So we're computing the 90th partial sum. Okay, what I would do in this case, okay, this is clearly arithmetic. To go from one term to the next, we're always adding 2. So the common difference here is 2. Okay, so we know the common difference. We know the first term is 1. Okay, you know, you could count out the first 90 terms here. Okay, you're skipping, you're going with the odd numbers here. I don't want to sit here and do this. Okay, I'm worried about making a mistake on what exactly the last term is. So I'm going to go ahead and apply the second formula here since I know the first term and I know the d value. Okay, so I'm just going to apply the second formula. Sn is equal to n divided by 2 times 2a1 plus n minus 1 times d. Okay, we want n to be 90 because we're adding 90 terms in the sequence. Okay, so we're computing the 90th partial sum. Plug in 90 everywhere you see n. Okay, so we're going to get a1 we know is 1, and then so we'll have 90 minus 1 times d. The d value is 2 because you're doing the odd integers here. Okay, All right, so we just need to simplify this. This is going to be 45 times 2 plus 89 times 2. Okay, so I'm going to go to my calculator. I will compute what's in the brackets first. We have 2 plus 89 times 2. Then we need to multiply this by 45. And so the sum of the first 90 positive odd integers is 16,020. And that's it. Okay, this is a lot easier. I know you have to apply a formula, but it's a lot easier than writing out the first 90 terms and then trying to add them all up.